In this video, we will practice solving some word problems or applications where we are given two vectors acting together and we have to find the resultant vector, the resultant magnitude and direction. In the World Rowing Championship, James Coven was the world champion for 1997. Suppose that while training, Coven was warming up by leisurely rowing directly across a river at a rate of 4 miles per hour. The current was flowing at a rate of 3 miles per hour. Determine the resultant velocity of the boat. Now, in the wording of the problem, it just says that he is swimming directly across the river at a rate of 4 miles per hour. It doesn't say whether he's going north, south, east, or west. So I'm just going to arbitrarily pick a direction scheme because that will not affect the numerical value that we get at the end, but it will help us organize the problem. So let's just imagine that the river is flowing from north to south, and let's imagine that Coven is swimming across the river from west to east. So this vector will represent his 4 miles per hour swimming across the river, let's say east. And now I'm going to have this blue vector representing the flow of the current, which was 3 miles per hour, and let's say south. So we are to find the resultant vector, which is going to be like this. Now, we're supposed to find the velocity. That's going to be represented by vector r. And the word velocity automatically includes the magnitude and the direction. This problem will be relatively simple because the two vectors involved, the speed of Coven swimming across the river and the speed, the velocity of the current, one of them is horizontal and one of them is vertical. So we can just go ahead and find the magnitude and direction immediately. The magnitude of the resultant vector is just going to be the square root of 4 squared plus 3 squared. So that magnitude is just going to be 5 miles per hour. Okay, now let's talk direction. Whenever you're talking about direction, I think it's a good idea to make yourself a little diagram. If we were going to picture this on an XY axis, this resultant vector is going into the fourth quadrant, if we look at it this way. If you were to make a little triangle out of it surrounding the reference angle, which would be right here, then we have 4 and we have -3. We could find the measure of angle r using tangent. The tangent of r should equal -3/4. I'm just going to put 3/4 because I'm just interested in the positive value of r. So I'm going to ignore this negative sign. So the tangent of r is 3/4. So the measure of the reference angle will be the inverse tangent of 3/4. Okay, so we can just use a calculator to evaluate this. Make sure your calculator is in degree mode. So inverse tangent of 3 divided by 4. So that's 36.87. So 36.87 degrees. That's the reference angle. Okay, now when we give a standard direction, we talk about it in terms of measuring from due east, the positive x-axis. So let's go ahead and talk about the direction this way. And I will call this angle theta. So the direction theta should be what we would get if we subtract 360 minus 36.87. All right, we were on our way to 360 degrees, but we stopped short by a value of r. So we're subtracting r. So theta turns out to be 323.13 degrees. So the velocity of the boat, if we just put this together, all right, velocity consists of the magnitude and the direction. So the velocity is 5 miles per hour at 323.13 degrees. Problem number 2. A brand new cruise ship leaves port and sails for 80 miles north 40 degrees east. Find the horizontal and vertical components of how far the ship has traveled. Let's draw ourselves a diagram. Okay, so here is the compass rose, north, south, east, and west. Now, when they say north 40 degrees east, when a direction is given in this format, it's telling you start by looking in this direction and then turn this many degrees in this direction. So if you begin at north and then you turn 40 degrees to the east. So you're supposed to imagine turning 40 degrees this way and then imagine the vector that you would have. So in other words, this angle right here should be 40 degrees. Okay, and don't forget the magnitude of this vector is 80. So now we're supposed to convert this over into horizontal and vertical components. So in other words, if we were to make a right triangle out of this, we're supposed to find the horizontal change and the vertical change. Well, look. We often talk about a vector in terms of the magnitude and the direction, r and theta. So right now we have the magnitude is 80, and the direction we can get from the 40. When I talk about magnitude and direction, r comma theta, the direction that I want is going to be measured from the positive x-axis. It's going to be measured from the east in a counterclockwise manner. So if this angle from north is 40 degrees, then the direction that I'm interested in is 50 degrees. I'm just subtracting from 90. So that's the theta that I'm going to use. All right, so I've got r and theta. The magnitude is, I put 8, I meant 80. The magnitude is 80, and the direction is 50 degrees. Now I'm breaking it down this way because given r and theta, magnitude and direction, the component form of a vector is going to be r cosine theta, comma r sine theta for the horizontal component and the vertical component. So now that we have r and theta, the magnitude and the direction, we can break that down as 80 cosine 50, comma 80 sine 50. And then we can just use our calculator to find the decimal approximations. Okay, so if I do 80 cosine 50, that's 51.42. Now 80 sine 50, that's 61.28. All right, and the units here are miles. So this is miles, and this is miles. And that's what they were asking us to find. All right, the horizontal and vertical components. So there you go. All right, we have been building up to a problem like number 3, where we have two vectors and neither of the directions are simply north, south, east, or west. So this is going to be a little bit more involved. An airplane is flying at a speed of 600 miles per hour at a direction of north 65 degrees west. It encounters a 175 mile per hour wind at a direction of north 20 degrees east. Find the resultant speed and direction of the plane. First, some notes. Let me give you the overview here. These notes describe how to find the resultant of two vectors when the directions are not simply north, south, east, or west. We are going to do these 4 steps. Step 1, we're going to determine the magnitude and direction for each vector. And at this stage, when I talk about magnitude and direction, I'm going to use r and theta. I'm going to convert, in step 2, I'm going to convert the magnitude and direction into component form x comma y using this little formula. R cosine theta will give me the horizontal component, r sine theta will give me the vertical component. I'm going to do that for both vectors. The reason why is so I can do step 3. In component form, it's easy to add. So in step 3, I will add the two vectors in component form, and that will leave us with the resultant vector in component form. But then step 4, we need to turn the resultant vector back into magnitude and direction, and that'll give us the final answer. So this is the flow, and this chart is an example of a good way to organize your work. So I would recommend making a chart similar to this one. And that's what I'm going to do right now. Okay, so here's how to use this table, this chart. So in the first column, I'm just going to indicate that we're going to be recording the magnitude and the direction. And in this row, we will do component form x and y. But in this column comes the first vector, which is the plane. So we have the plane flying. And the other vector is the wind. And then we will have the resultant. Okay, so for the plane, let's talk about the magnitude and direction of the speed of the plane. So let's see, the plane is flying at a speed of 600 miles per hour. Well, that's the magnitude, 600 miles per hour. And now let's talk about the direction. So the direction here is north 65 degrees west. So let's talk about that direction. All right, let's make a little diagram, and this is north up here. So when they say north 65 degrees west, in that format, they are saying start at north and then turn 65 degrees towards west. Now west is over here. So if we start north and we turn 65 degrees in the direction of west, that's going to put us here in the second quadrant. And this is 65 degrees. Now when we talk about magnitude and direction, and the direction is theta, this direction, this theta, is the type that is measured from the positive x-axis. In other words, counterclockwise starting from east. So this is the angle that we need. So this 65-degree angle that was sort of given to us, we can use that to find the direction, but this theta should equal 90 degrees plus the 65. So of course that's going to be a total of 155 degrees. And hopefully you can see that I'm doing this because as I travel from the positive x-axis to here, I've gone 90 degrees so far, and then I have to go the extra 65 degrees that they gave us. So magnitude and direction, the magnitude was 600, the direction is 155 degrees. Okay, now we need to do the same thing for the wind. Let's make another little diagram for the wind. And again, this is north right here. So the wind is blowing at a direction of north, 20 degrees east. So again, that means start off facing north and then turn 20 degrees towards the east. All right, now the east is over here. So if I start at north and I turn 20 degrees towards the east, then my vector is here, and this is 20 degrees. Now again, the direction, the theta, has to be measured from the positive x-axis, counterclockwise from east. So if this is 20 degrees, then this theta must be 70 degrees. All right, I'm just subtracting from 90. All right, if I had gone all the way to north, that would have been 90 degrees, but I had to back off. I had to subtract the 20. So in this case, the theta was equal to 90 minus the 20 that they gave us. Okay, so that's the direction is going to be 70 degrees. But you know what? I forgot to mention the magnitude. Where was that? So it encounters a 175 mile per hour wind. So the magnitude is 175 miles per hour. And then the direction is this 70 degrees. So let's stop and think about what we've done so far. Step one was to determine the magnitude and direction for each vector. We've now done that. Step two, it's time to convert the magnitude and direction to component form, x, y, using the little formula r cosine theta, r sine theta. So that's what we're about to do now, component form for both vectors. Okay, so remember r cosine theta. So that's so for the plane speed, that's going to be 600 cosine 155. I have to write really small because this is these are big numbers. 600 sine 155. All right, just barely fits in there. And then for the wind speed is going to be 175 cosine 70 degrees, and then 175 sine 70 degrees. All right, so all I really need to do is evaluate this in my calculator. I'm not going to show them all. I'll do one of them on camera and the rest I will do off camera. Make sure that your calculator is in degree mode because that will throw things off. So, for example, 600 cosine 155. So 600 cosine 155. Okay, that is negative 543.78. Similarly, the vertical component will be 600 sine 155, and that's 253.57. So there we have the component form for the plane speed. So let's do the calculations for wind. I'm going to do that off camera in the same way. So the wind velocity in component form is 59.85, 164.45. So now we have completed step 2. We converted the magnitude and direction to component form for both vectors. Now it's time for step 3. Add the vectors to find the resultant in component form. So let's just go back. In component form, it is easy to add these vectors. We are simply going to add corresponding parts, corresponding components, and we should be able to write the resultant in component form quickly. So the resultant in component form is negative 483.93, 418.02. Again, I simply got that by adding the horizontal components. That gave me the negative 483, and then I added the vertical components, and that gave me the 418. All right, so we have now completed step 3. We added the vectors to find the resultant in component form. Now it's time for the fourth and final step. We need to determine the magnitude and direction of the resultant, because that's what we are really being asked for. All right, so we need to take this component form and use it to find the magnitude and the direction. So, let's see, I'm going to need a little bit more space over here. Let's talk magnitude. I think I'll do the magnitude over here. All right, the magnitude. All right, we can get the magnitude by using the magnitude formula, which goes, you know what, I'm going to need even more space. Let me just spread this out. Okay, the magnitude formula says I'm going to take these components, negative 483.93, I'm going to square it. Then I'm going to add 418.02, and I'm going to square that. That should give me the magnitude. I'm just going to put this whole thing in my calculator right now. I've typed it in my calculator, boom, 639.48. Okay, that's the magnitude, and this is miles per hour. So I'm going to put that on my chart as well. So the resultant speed is 639.48 miles per hour. All right, now we need to find the direction, just like we had for the plane velocity and the wind velocity. All right, we want to find the direction. And just like we use these little diagrams to determine the direction for the plane velocity and the wind velocity, let's do that one more time for the direction of the resultant vector. All right, so here's north up here. So look at this component form. It is left 483.93 and then up 418.02. Left and up. So that puts us in the second quadrant. So let's draw ourselves a vector going into the second quadrant like this. Let's make a little triangle out of this. All right, surrounding the reference angle here, which I will call R. Now this is left 483, so that means we have our negative 483.93 horizontally, and up 418.02, so our 418.02 is vertical. So we can find this reference angle R using tangent. So we know that the tangent of this reference angle R should equal 418.02 over negative 483.93. Now I'm actually going to ignore the negative sign, because I just want the positive value of this reference angle. I don't need the negative sign. Okay, so when I go to find the value of R, I will do the inverse tangent of 418.02 over 483.93. Okay, so let's go ahead and find out the value of the reference angle. So here it is typed into my calculator. Boom! That is 40.82 degrees. So that is my reference angle, is 40.82 degrees. Now that is not the angle that I'm going to put up here. That's just a reference angle. So what I actually need, the direction, which I call theta, has to be the angle that's measured from the positive x-axis, counterclockwise from east. So what I need to do is subtract from 180. I was on my way to 180, but I had to stop short by a value of R. So it's going to be 180 minus R. So I have to do 180 minus the 40.82. And that's 139.18 degrees. And that's what we will record on the chart. The direction of the resultant speed, the resultant velocity is 139.18 degrees. Now, we are almost done, but there's one last little thing that we have to do. We cannot quite record our final answer in this way. I'm looking at the direction. Now, in the original problem, they used a different method for giving us the direction. They did not give us the direction as an angle measured from the positive x-axis, like the way we're doing. Instead, they use this other method where they start with north and then they tell us how many degrees east or west it is from there. So we have to record our final answer using that type of direction. So look at our resultant vector shown in this picture right here. We have to start at north and figure out how many degrees west we're going to go to get to this vector. Now notice we know R. R is 40.82. So we can find how many degrees to the west this is. We can find this angle by subtracting from 90. All right, these two have to add up to 90. They're sitting right here inside of the 90-degree quadrant. So I'm just going to go 90 minus 40.82. Okay, so this little question mark that I just put is going to be 90 minus the R, minus 40.82. Okay, what's that? That is 49.18. Okay, let's see if I can erase this question mark without erasing everything. Okay, so this little angle right here is 49.18 49.18. So here's how we will record our final answer. We're supposed to write the magnitude and direction of the resultant vector. The magnitude is right here, all right, 639.48 miles per hour. So now we just need to add on the direction, and now we're going to do it the same format. So we need to start off by saying north, just like they did when they gave us our direction. Start off with north, and then we are to turn 49.18 degrees, all right, that's how far we had to turn to get to the resultant from north. And we are turning in the direction of west, all right, that's where we're headed. So we say west. So this is your final answer right here in this box. All right, the resultant velocity is going to be 639.48 miles per hour north, 49.18 degrees west. That's how you record your final answer. Hey guys, that's going to do it for this video. Go ahead and click over here to watch the next video, and click over here to subscribe. That way you'll get every new video delivered right to your home screen.